Thank you. I want to thank the organisers and everybody for giving us the opportunity to talk about this project. It's one that's been ongoing and will go on for another year or so. Just what you've seen up there is 4 of the published ebooks at the moment, and I'm going to explain a little bit about the project and the concept, and then give you a demonstration of the soil organic matter one, because I think that's most relevant to what the concept of World Soils Day today and what we're talking about. The concept grew from discussions mainly with Professor Daniel Murphy, and I was really pleased to hear Brendan, if he's still here, talk about that program that he and Andrew Werrett and Francis Hoyle had through Perth NRM, that benchmarking of soil organic matter. We had a big role in another project benchmarking the soil acidity or soil pH over that time as well, and we're doing a little bit with the Department of Water and their name, and Malcolm will correct me on the proper name at the moment. We're going to do a smaller project on that to do a little bit of revisiting and finding out where things have gone and how they've changed. Those projects have generated a huge amount of information which was stored largely on the soil quality website, which is run by the university. They also produced a massive number of fact sheets and information which was really well received. But in terms of transferring it across to farmers, even though it's sat on websites as PDFs and things like that, there was a difficulty because most farmers do not want to come back after a day out on the farm to sit down in an office or sit down and get out an iPad or sit at the computer to try and source this information. So there was a real desire to have that information available to them, that they could access it in a way that they were able to absorb it and read it and understand it while the tractors were driving themselves, which most of them can do these days. So they had time there, accessible time, but no real way of getting hold of it because, let's face it, the internet, and this room is an ideal example, the internet is not all that flash once you get over the Perth Hills. That's just the way it is at the moment. We'll get there eventually, but that's the way it is. So we had all of this information. We had it in soil acidity guides from the department, great information, great feedback on what's in there, but again, it's a book and people have got to come and grab it and look after it to get hold of it. So our concept was that we could put it together. We could put it together in a PDF, and people could flick through it and read it, and that really is a bit old-fashioned. The things that we have at our fingertips now, tablets and iPads and phones even these days, just are capable of so much more, and people expect so much more as well. They expect a much higher level of interactivity and a better way of accessing information at the level that they want it to. So one of the concepts with these ebooks is that we're providing layers of information that somebody might just want to grab the headlines, the bits, the pictures, and flick through and get an understanding of the topic at that level. Others are going to want to delve down into a bit more detail and assure themselves of the quality of the information and where it's come from and the evidence that's produced it. And then others, and in this case, we've made them available or targeted them to farmers, to students, agribusiness advisors. When I say students, to university students. So these books so far have been used by the universities to give their students an up-to-date, hot off the press if you like, some of the research and the information that we've developed on managing various aspects of soil quality. They're called multi-touch books or digital books for good reason, and I'll demonstrate that to you shortly. I should make sure that I acknowledge Daniel Murphy and the concept. The books are produced by Soils West, which is an alliance between the Department of Primary Industries and UWA at this stage. It's not an exclusive alliance, but it's an alliance there, and the overall aim of it is to improve the capacity across the board for rural Ireland, and in particular soil research and development, and tacked onto that the extension of the information that's developed. Certainly not an exclusive alliance, but it's one where we think we can 1 + 1 is going to equal, or does equal, more than 2. So Soils West was the publisher of the first two books, and the second book, I should acknowledge, had support from Untitled NRM as well. And after the first two books were published, so the first book, I should say, sorry, I'll just skip back, is called Constraints to Plant Production. It's an introduction to the series and was funded by UWA as a concept and were we going to be able to achieve the aims that we were setting out to do. I think we did that pretty well. The second book, called Integrated Soil Management, was a good go at pulling everything that we knew at the time together in terms of managing soils. As I said, with support from Untitled NRM and a couple of the other NRM bodies through Untitled NRM. At the point, once we've got those first two books out, the Grains Research and Development Corporation, GRDC, saw the value of housing this information in an easy to access vehicle, and they negotiated a project with Associate Professor Fran Hoyle at Soils West at UWA, and to complete the series, and what we perceive as a series of 10 books in total. So the third book there, which I'll demonstrate today, is Soil Organic Matter. The fourth one, published towards the end of last year, or no, earlier this year, was Soil Acidity. So I should know that. It's been an interesting year. All of the books are and will be available as a free download from Apple Books. So they work at the moment on iPad and iPhones, and I'm sure I'll get a question on that towards the end, which I'll address. The rest of the books are book 5, which will be coming soon, is Soil Biology. That'll be about twice as big as these books, because we've taken the approach that soil biology has both good and bad elements to it. It's got pathogens and it's got beneficials. And we put them together because often soil biology is seen as all good, or it's seen as all bad, depending on which sort of way you're looking. And it really has to be understood as a joint thing, that it's a whole ecosystem of environmental things that happen in the soil. So it's got both concepts in there. 6 books will be soil compaction, then soil water repellents, sodic and alkaline soils, nutrition, and the final one in the series we see will be gravel soil. So when you have access to Wi-Fi or you've got good data download, go to Apple Books, search for soil quality, and you'll be able to download those books and have a look through them. Just now, I'll give you an example of this book. Yeah, a little touch. Here we are. So first of all, when you open up the book, you'll see that there's a section on the bottom, which is our table of contents, which allows you to flick through from section to section, getting through the pages, so you're not flicking backwards and forwards like the old paper books. But if you tap on the bottom, and unfortunately we can't show you where I'm touching, but just trust me, I'm touching at various bits on the screen that bring up the different things. So there's the page, there's the introduction to the soil organic matter page. There's a bit of information here that we've got ISBN and all of the other information. A list of the books, and straight away you've got an example down the bottom there, abbreviations and acronyms. If I just touch on that, it brings up a whole list that you can access of all of the various chemical symbols, things that have to be used in the book that are all there just ready for you to see. Moving forward, you have the people who are involved and then the acknowledgements. And then we start section 1, and at the highest level you can get an idea from a couple of sentences written under that layer that introduces the section. The next level that we have is the dot points down the left hand side, and that's a consistent theme all the way through the book. Gives you extra information and just tries to expand a little bit. We then have the body text, and interspersed between we have various movies, delivered by experts or people in their trade. We don't restrict it. Well, what we try and do is get the right person on the job on the video to tell you a little bit, keep them fairly short, two maximum 3 minutes, bit of information about what the topics are. We get more information obviously through the heading and through the captions. So an example here for in bold, Southwest Agricultural Region. If I touch on that, you can access a glossary term. You're not going searching through the back to try and find out. It's straight there. If you've got more information as well, you can go to the glossary itself, where there's an expansion of the information, so you can understand very clearly what we're talking about in terms of the books. They're focused on the Southwest Agricultural area, through the grain belt, and pull in information from some of the higher rainfall sites as well. So that's sort of another level. Then, as an example, and this is some of that soil carbon information that we heard about this morning, about the benchmarking information. This chart is on soil organic carbon in percent, in the top 10 centimetres. And then there is a similar map converted to tonnes per hectare. The information down the bottom on this little button, just touch on it. So there's more detail there, just scrolling through that box. There's more detail in the map, and then I'll just play a few moments of this. We delve in and we try and explain the science. So this is where the university students are going to get their value out of what they're actually looking at.
Over 1,300 soil sites across the southwestern agricultural region of Western Australia were assessed for a range of soil properties and site variables to determine the factors associated with changes in total soil organic carbon to a depth of 30 centimetres. Site variables including soil type, bulk density, clay content, pH, electrical conductivity, water repellence, disease,
leave you in suspense, go and get the copy. Otherwise, seriously, there's so much packed into these books, I won't be able to get through in the time that I've got. So I didn't look at my watch, so I'll jump up and down when a few minutes left. So here's another example of an interactive thing that we offer. So just where you see the touch button, that indicates that you might want to just click on that and you get some extra mineral components of the soil, salt, sand and silt that we heard of from Henry when he was cutting the cake. That's the guts, the basis of the soil that everything else is built on. And if I click on the soil biota tab there, we get a bunch more information, some ideas of just what sort of things live in the soil and are there. Well, I touch the close button and we go back. Flick through, there's another interactive there in terms of explaining the humus and particular pieces of the organic matter that we can deal with. It's an animation here.
Soil organic matter cycles continuously between its living, actively decomposing and more stable fractions. When plants and animals die, they are decomposed to become part of the soil organic matter. Soil organisms fragment and consume organic residues, gaining energy to grow and reproduce. Fresh residues are broken down into smaller pieces and become part of the particulate organic matter fraction. As the material is further decomposed, a proportion of more biologically stable material enters the humus pool.
You get the idea. Again, moving on to another section, we get another caption and we get some more detailed notes. We get a chart, an animated chart where the implications of what you're looking at are presented. Something like this, touching on the little icons, you get more detail. It's just layers of information that you can access all the way through. I think Clive was talking this afternoon, I haven't seen it. Yeah, there you are. At the risk of pinching a little bit of your thunder, you've just got such a beautiful quote that I will play this. Clive?
Greg and I purchased this property nearly a year ago. We both come from northern pastoral backgrounds, so farming's fairly new to us. Traditionally, we would have considered ourselves cattle producers, but the more time we spend down here, we can't have healthy cattle unless we have healthy pastures, and we can't have healthy pastures unless we've got healthy soils. So we really need to become soil farmers before we can
say no more. So, and that sort of is another aspect of the books, is the, the farmer experience backed up with the research that, was involved and goes through. Various other case studies and levels of information that are in here. You want to get through to one which I'll just take you through. Well, actually we could, if you don't want to just flick through like I'm doing, and you can see all of these things here like this, basically we can go back to our table of contents and then we can flick through a section at a time. So we go to something like this, which looks like a fairly complex chart, but again, clicking on an aspect of the chart, there's quite a bit of detailed information contained in there to help explain it to you. Various things from, in the laboratory, demonstrating simple methods to visualise the amount of sand and particle size analysis. But there is really too much to demonstrate all at once, and I want to go through, there's another video in that aspect. Quick one there, and I'll leave you.
I'm often asked why soil organic matter levels are different in different soils. We think about a soil, the pieces of plant material that drop on the soil start to get broken down by microbes. The amount of organic matter that enters the soil is very dependent on plant productivity. And if we think about this as a tipping scale, on this...
I know you all want to hear it all. I've got to move on. A wall like this, which talks about all the different things in terms of management that affects soil organic matter. At face value, it's just a nice, simple half a dozen things that affect it. But if we touch on them, we've got a whole bunch more information about each one and how and why it does it. Where carbon ends up, various studies, more studies there. That's one from Fran at Stuart McAlpine's property, where they did a 12-year study and added over 100 tonnes of extra organic matter and monitored and looked at and measured the organic change, or the change in organic matter over time. And I just want to get to this last one here, and then one more thing after that. But this is a 2-minute video which really explains what we're talking about today.
So here's some data from a trial in WA that has been running for 18 years. After 18 years, very simple trial, either burnt or retained, same carbon value. Retained system has more particulate organic matter or labile carbon, the stuff that microbes can eat, and it has a larger microbial population, 50% larger. Two soils, same carbon value, different biological functioning. The straw retained system has a far higher level of biological cycling, and that actually translates in this trial through to additional nitrogen supply to the crop, and that translates through to a grain protein increase. But why might we think that after 18 years, we've been burning all the straw, we haven't built up any more carbon? Let's think about that. Below ground, our root systems are the same. If we're burning the stubble on the surface, or we're retaining the stubble, our carbon input from our root systems are the same. In a wheat crop, about half of our carbon is below ground in the roots, so we're not changing that. Above ground, when it's burnt, we're putting a match to it, so the carbon goes up as carbon dioxide when we burn. In the stubble retained system, the microbes are still breaking down that organic matter, they're still breaking down that stubble as an energy source, and still releasing 75% of that carbon as carbon dioxide. Our burning efficiency is probably no more than 75%. So really what we're doing is we're not changing our total carbon balance whether we're burning or retaining. What we're doing is we're changing whether we allow the biology to cycle that and allow for greater nutrient cycling in the soil, or whether we're putting a match to it. But it's very difficult with management practices to sometimes change carbon because the biology is still breaking down that organic matter.
So I'll just finish off. A couple more pages and I'll show you. What I haven't stressed, or I think I have stressed, but I'll just reiterate it. The information that we're providing is based on the latest research. It's based on peer review evidence. We've done the tests to see what happens if we do and we don't, and to understand that mostly in systems things. I think a lot of the work is now done where we have multiple inputs and multiple levels of stuff. To make the book easy to read and easy to get through and you know, access the information, what we've done is put all of the references and all of the media credits and everything where we've used information and referred to in the back of the book, and reference them down to each of the various aspects that we've referred to and where they've come from. I'll leave it there. I'd like to demonstrate the rest of them, but look, please go and download them. They are free. Getting textbooks like that, I mean, it's a cheap iPad if you have to buy one.
So, where can we get the books?
Okay.
So,
you do need an iPad or an iPhone because they are done in the Apple software, which allows for that richness of the media and the combination of everything that we can put in there at this point. So if you've got those, you just go to the Books app and go to Apple, the bookstore, and search for Soar Quality. The 4 of those, just like that, will come up, and you just download them. Yep. Cool. Because they've all been paid for through research grants and through things that have already been done, and yeah, put them together. So it's not right to be charging again for them. They contain all of this information. And I think it would be remiss of me not to give a thank you to everybody that's been involved, everybody that's contributed to the example with Blythe, and we do really appreciate it. Some of the things are repackaged with permission and reused and just brought together to try and cover this whole area of soil quality.
thanks, Chris.
I do have to apologise, and this is a question, all right, but I've probably used up the time. I do have to apologise, I do have to nip back to Perth. Some family stuff came up yesterday, so.
Yeah, well, we have your contact details. We're happy to share that out if you guys want to follow up.
Absolutely,
later on.
yeah. Or don't use a long name, Christopher. That's only my mum calls me that. Just search for Chris Gazey. There's not too many of us in the world, and you'll find WA or contact details or whatever. Yeah.
Thanks.
All right. Thanks, Shane.